Hello and welcome to another video with Fully Theoretical. We're working through the geometric series word problems, so the second set of them over here. I apologize for the noise. I've got my dishwasher going in the background, but hopefully you can still hear me. So let's get to it.
We're told a monkey is swinging from a tree. On the first swing, she passes through an arc of 24 meters. With each swing, she passes through an arc 1/2 the length of the previous swing. So what's going on here, let's say this is the top of the rope or the vine that the monkey is swinging from. And so on that first...
Okay. Before we even do anything else, we already know it's a geometric series, so in theory, it'll use the exact same formula as before, unless it's something completely new. So the first arc, hold on, let's go back over here. So let's actually resize this a little bit. On the first swing, it's an arc of 24 meters. So the first swing is 24. So Sn equals 24. She passes through an arc of half the length of the previous swing, so that means the 1 minus is minus 1/2 to the n. 1 minus 1/2.
Swing, I could draw a little monkey here. So this is my little monkey. So on that first swing, the monkey will go 24 meters. So might do something like this. And that arc is 24 meters. And then on the second swing...
Oh, yeah. See, look, I didn't even read the question all the way. And question number 1, where's my mouse at? Here it is. So question number 1 is this right here. So I answered the question before, just as a setup. Okay.
Swing back at an arc half the length of the previous swing. So then she would come back, and then it would be half the length, and so maybe swing back over here. And then on the next, so that would be 12, and then on the next swing, she would swing half of that, which would be 6 meters. And so she might swing like this, and that makes sense. That's consistent with our experiences swinging from trees, for those of us who've done that. So let's look at the first choice. Which expression gives the total length the monkey swings in her first n swings? So pause the video and see if you can do that. And you can express it as, actually express it both two ways. Express it as a geometric series, but also express it as the sum of a geometric series if we were to actually evaluate it. So let's do this together. So we already said on the first swing, the monkey goes 24 meters. Now on the second swing, and I gave you a hint when I said to express it as a geometric series, she swings half that. Now I could just write a 12 here, but the half is interesting because that's going to be my common ratio for my geometric series. Every successive swing, the arc length is half the arc length of the last swing. So it's going to be 24 times 1/2.
What he's
and then on the
doing,
next swing, it's going to be 24. It's going to be half of this. So it's going to be 24 times 1/2.
what he's doing right now is setting it up manually, which, I mean, there's no reason to do that if you already know it's a geometric series. You just use the equation. Come on, Sal.
Times 1/2. So that's 24 times 1/2 to the second power. And so this would be the first 3 swings. Notice that the exponent here we got to the second power. So the first n swings, we are going to get to 24 times 1/2, not to the n power, but to the n minus 1 power. Notice after 2 swings, we only get to 24 times 1/2 to the first power. After 3 swings to the second power. So after n swings to the n minus 1 power. Now, as I said, we don't want to just have this expression. We actually want to know, how do we evaluate this? And the way we evaluate this is we look at the formula, which we've explained and we've proven in other videos, the formula for finite geometric series. So that tells us, I'll just write it over here, the sum of first n terms is a, where a is the first term, so that's going to be our 24 in this situation. It's a minus a times our common ratio. I already said that our common ratio is 1/2 to the nth power. So one way I like to remember it is our first term minus the first term that we didn't include, or minus what would have been the term right after this. All of that over 1 minus our common ratio. And there's other ways that you might have seen this written. You could factor a out, and you...
So a minus ar to the n. So a minus ar to the, yeah, okay. So this equation right here is the distributed version of this. So yeah, it's the exact same thing.
You might have seen something like this, a times 1 minus r to the n, all of that over 1 minus r. These two are equivalent. But now let's use this. So this is going to be equal to, actually I'll use this second form right over here. So our first term, a, is 24. So we're going to have 24 times 1 minus our common ratio, which is 1/2. To the nth power, well, we're talking about the first n swing, so I'm just going to leave an n right over there. All of that over 1 minus our common ratio, 1 minus 1/2.
So this is actually wrong because this would be 1 to the n over 2. You need some parentheses here.
So we could leave it like that, or we could simplify it a little bit if we like. 1 minus 1/2 is equal to 1/2. 24 divided by 1/2 is equal to 48. So if you wanted to, you could simplify to 48 times 1 minus 1/2 to the nth power. So either of these would be legitimate. Now the second part, they say, what is the total distance the monkey has traveled when she completes her 25th swing? They say round your final answer to the nearest meter. So pause the video and see if you can work that out.
Okay, all right. So he simplified it. Okay, I guess I can do that too. So, all right, this equals 24 minus 24 1/2 to the n over 1/2, which equals, because take this, multiply it by the inverse, right? So we end up with 2 over 1 times all that, or more simply 2, because 2 over 1 is 2, times 24 minus 24 1 over 2 to the n. Okay, so then we have 24 is 48 minus 48 1/2 to the n. Is that what he had? 48 times, okay, so he just didn't distribute that. So, because basically this is the same thing as 48 times 1 minus 1/2 to the n, because that's 48, that's 48 1/2 to the n. So it's the same thing. So cool. They wanted a simplified. So what expression, what they should have added to this is simplify your answer. And then, you know, then I would have actually done the work for it. Rather than just giving the raw formula over here. Oops, that is a really nasty circle. That's why I never use your mouse. Hold on. Oops. Whoa. Technology's freaking out on me. Okay. All right. Back to the video.
All right, well, we can just use this expression here, and we know that we are completing our 25th swing.
Okay, well, actually, let's just ask the question here. So what is the total distance monkey has traveled when she's completed her 25th swing? Okay, so basically, n equals 25. So what I'm going to do is I'm going to take my answer from the previous bit. I'm going to move it up here. Actually, first, let's just clear the rest of this, and I'll move it down below. There we go. So that looks good. So the total distance at n equals 25. So S sub 25 equals, now he didn't distribute this, he did not distribute this right here for his, but I'm going to do that while I write this out because it makes it simpler. So equals 48 minus, see, I got to remember this is a minus, not a times. So minus 48 1 over 2 to the 25th, which is a really easy, simple equation that I'm going to use a calculator for because I don't have the patience for that. So we have 0.5 to the 25th. Is this really, okay, yeah, that definitely wouldn't have done that by hand. So that multiplied by 48 is something really small. Okay. So basically it's 48 minus all of that. That does not sound right. What is the total distance monkey has traveled? The total distance traveled. So this is supposed to be the sum, right? The sum of it all. Did I punch this in wrong again? Man, I've been having a really hard go of this lately. So 1/2. This is clearly, okay, so first of all, this is obvious. Let's switch colors here. So this is obviously, man, I need to not use the mouse. This is a really small number. Really small multiplied with that. So which means did we forget a step? Because this, so 48, well, let's just see what Khan has to say because I feel like something's off.
So n is 25, and so we'll just put a 25 there. So that's going to be 48 times 1 minus 1/2 to the 25th power. Now this is going to be a very, very small number, so it's actually going to be pretty close to 48 meters. But let's see what this is equal to. We're going to round to the nearest meter. All right, so let's get our calculator out. And so let's just evaluate 1/2. I'll start this 0.5 to the 25th power, which as we said, as we predicted, is a very small number. And then we're going to subtract that from 1, so let's put a negative, and then I'll add 1 to it. And so that is very close to 1, and so my prediction is holding true.
Okay, no, I just figured out why this wasn't making sense. So basically, I was thinking that the first swing was 48, but that's wrong. The first swing was 24. So the sum of all the swings being really close to 48 actually does make sense. So here's what I'm going to do. I'm going to get two calculators going. That's the correct one. So let's grab the other calculator here. Here's the other calculator. So now we just take 48 minus 0. How many do we have here? 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 1, 4, 3, 0, 5, 1, 1, 4, 7, 4, 6, 0, 9, 3, 7, 5. And that's our answer. I'm not writing that down. I have a feeling that he didn't even bother to do the calculation on it. That's, that's a rounded example. So basically, it's 47.9. So it rounds up to 48, all the way down to tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths, 10 millionths. So down to the 100 millionth decimal, it rounds up to 48. So you have to go to the billionth, literally the billionths, in order to get to a spot where it doesn't round up to 48. So I'm going to call the answer 48.
So I multiply that times 48. Well, if we round to the nearest meter, we get back to 48 meters. So this is going to be 48 meters. And we're done.
All right, you're right, Sal. You're right. It's not 48, it's roughly 48. There we go. All right, so that is going to do it. Thanks for watching.